Teaching computers how to speak Indigenous language is more than just speech science. It's about connecting people with identity. It's about place. It's about land. I'm the CEO of Te Hiku Media, and we teach computers how to speak Māori. We're also Māori-language broadcasters, and amongst other things, we live video stream our cultural events as a way of providing digital access for intergenerational transmission of our Indigenous language and our culture. When I realized that, and knowing that I could speak the language proficiently, and having been raised in the culture, I felt an obligation to ensure that what had been done could perhaps be undone. Working through 30 years of archives is not a small task. We quickly saw that we needed to find a way, and at that moment, we decided to teach computers to speak our Indigenous language. What we have created is a system that operates at a 92% accuracy rate. It outperforms attempts by big tech companies throughout the world. And you might ask why. And the answer is, nobody knows us as good as we know ourselves. Nobody knows our language as good as we know ourselves. Nobody knows our ocean, the ocean currents, the winds of which we have over 200 names, the rains of which we have over 200 names. Artificial intelligence is a way for us to not only preserve languages, but contribute to the revitalization of those languages.
There's a myth that financial education in the workplace is a nice to have. I believe that it's a need to have, and we see that every day. 57% of employees say that financial stress is their number one source of stress, and this impacts their work when they're on the job, increasing absenteeism, lacking as much focus, and actually having an implication of billions of dollars of lost productivity across the workforce. We also know that greater than 70% of employees seek and would like access to professional financial help.
So it's not about how much money you have. It's about how do you make your money work for you and make your money meet your goals. So for example, the idea of compounding, savings in excess of your spending. Also, learning these habits early is very important. For example, when I was a teenager, I became interested in finance and the markets. So I started working as a part-time stockbroker when I was in college and learning about the markets and investing, and that was very important. The younger you are, the better in terms of building good habits so you can save and meet your retirement goals later in life. Compound interest benefits from time. So it's your ability to make your money work for you. So the more that you can put your money to work from an early age, even if it's just a small amount of money, and letting that compound and earn money on itself over time allows you to generate income in a passive way. And all of that helps you build wealth as you go on.
It's like going to the gym. You do not get better overnight. So you're carrying those weights and gradually you're adding more weight, and that's just how financial literacy is. Today you start with $5 or £5 or £5. The next month you add towards it. The next, you keep getting better. You start having harder conversations. You start trying to take risk and you start learning. It's a continuous journey. So if you hold back, 10 years plays a critical role in your financial investment journey. Time is a critical component. So the more you wait, the more you're cheating yourself or denying yourself the opportunity towards financial independence. So if it is $5, you can do. If it's $10, you can do. If it is $20, whatever you have, you just have to start now. A lot of people always think financial institutions are out to get them. So it could be things like terms and conditions or even what could have happened in the past. So they always see financial institutions as the bad guy, people that just want to take their money, that are putting in hidden clauses to catch them. So how do we then demystify and say that, listen, that's not always the case, that they're actually safe and fantastic products that one could actually keep with financial institutions and actually build wealth in the long run. So education plays a critical role. How does insurance work? What is the money market, mutual funds, amongst others. Also, let me give you an example. We know of a person that was investing in the stock market thinking the stock market is a safe instrument, but that's not how the stock market works. Sometimes it goes up, sometimes it goes down. But when they don't have that knowledge, if their money goes down, then the financial institution is seen as the bad guy. So information is very important.
In aerospace, there's a new class of materials called high-entropy alloys. They're remarkable, but they're very complex. Most alloys only have 2 principal elements. These alloys have 5 or more. So they're much more complex, and the material space is enormous. I mean, if you think about taking any 5 elements and combining together, I believe there's something like 2 billion possible combinations. So there's no way that you can build 2 billion samples of 2 billion different materials and then test them in the lab and figure out which one's the best one. But if you had a computational method, you could do that. And you can contemplate using a quantum computer to explore this material space and find these super high performance alloys that could be then used for making high performance aircraft, for example. And instead of doing it in 10 to 20 years, one could perform that exploration in 1 to 2 years. classical computers cannot easily simulate chemistry and materials because these are inherently quantum systems. For example, in order to just represent a molecule or a material, the more atoms and electrons you add, the number of parameters that you need to keep track of grows exponentially. So pretty quickly you get to a not so large molecule that can't be exactly represented on a classical computer. You have to start making approximations, and that leads to errors and so on and so forth. On a quantum computer, those sorts of systems grow much slower. And what that ultimately means is that a quantum computer can simulate much larger, much more complex systems. And we can therefore then think about using a quantum computer to accelerate the development of new materials.
Bacteriophages have been discovered more than a century ago. They are the most abundant biological entities on the planet. So this diversity and this specificity make them complicated to be used as antibacterials. But with the development in the biotech sector, it's now possible to use them and develop personalized, highly efficient, and sustainable alternatives to antibiotics.
Every time you use an antibiotic, which is a chemical molecule, and you keep using the same chemical molecule, bacteria evolve and they become resistant to this particular molecule. Imagine that there's more bacteriophages on Earth than every other biological entity combined. And you have to find the right one and put it in the right time, in the right place to have a therapeutic effect. This is one of the main reasons why phage therapy has not emerged yet. And this is where AI comes in. Instead of having to test everything manually, we use several different types of inference methods, so machine learning, classical, but also Gen AI now, in order to find the best bacteriophage candidates, the best bacteriophage combinations, and then test them in the lab.